Hello viewers, welcome back to our YouTube channel. In today's video, we are going to learn about graphs of a quadratic function, and our focus is going to be on axis of symmetry. So when we say axis of symmetry, it's just an imaginary line which is dividing the graph of a quadratic function. So the graph of a quadratic function looks like a parabola which can be moving up or it can be moving down as you see here. So it can be moving down in this direction or up in this direction. So we can draw an imaginary line to divide this graph into two equal parts, and this imaginary line that we draw is called the axis of symmetry. So the imaginary line here is called the axis of symmetry. To understand the axis of symmetry, we can take it to be a mirror. If we stand in front of a mirror, you realize that your image will be facing you directly. Your right hand will be facing your right hand, your left hand will be facing your left hand. You don't see yourself, the image in the mirror, as the same direction as you are standing. You realize that the direction changes. So that's how the axis of symmetry too is like. Now, if you are drawing the graph of a quadratic function, if we start from here and draw and get to the axis of symmetry, we realize that now the direction is changing. So the direction is now going to change when it hits the axis of symmetry. So you realize that your direction changes when you look at the image in the mirror. The same here. When you hit the axis of symmetry, your direction is going to change, and now you are going to see that this part of the graph is facing it. This part is facing this part is facing this part. So that is what is called the axis of symmetry. This imaginary line that divides a graph into two equal parts is what is called the axis of symmetry. Now you can get a generalized equation for the axis of symmetry. And to get it, we are going to use the completing of squares to find the axis of symmetry. We are going to find an expression for the axis of symmetry. So if we have a quadratic function as f of x to be equal to ax squared plus bx plus c. We are just writing the generalized quadratic function. So if you have f of x to be equal to ax squared plus bx plus c, now we are going to equate this function to 0 so that we will get a quadratic equation. So we end up getting ax squared plus bx plus c is equal to 0. Now, when we are using the completing of squares, you are supposed to send the constant to the right hand side. So we are going to get ax squared plus bx equal to negative c. The next thing is to ensure that the coefficient of x squared is 1. So we are going to divide each term of the equation by a so that the coefficient of x squared can be 1. So if we divide each term by a, we are going to get, now a is going to cancel a here. So we are going to get x squared plus b over a x equal to negative c over a. What we are supposed to do next is to find half the coefficient of x. So if you find half the coefficient of x, which is b over a, we are going to get b over 2a. So we are going to square our results and then add it to the right hand side of the equation and also add it to the left hand side of the equation. So we are going to get x squared plus b over ax plus b over 2a all squared equal to negative c over a plus b over 2a all squared. So from here, we are going to take the terms that are squared, add those two terms, and then square all of that. So we are going to get x plus b over 2a, all of this squared to be equal to negative c over a plus b squared over 4a squared. Now, to simplify the right hand side, we are going to get x plus b over 2a all squared to be equal to, now the LCM here is 4a squared. 4a squared. A goes into 4a squared, 4a. 4a times c is going to give us negative 4ac plus 4a squared goes into 4a squared, 1. So 1 times b squared is going to give us b squared. So from here, our equation can be written as x plus b over 2a all squared is equal to negative 4ac plus b squared over 4a squared. Now we can write our expression as on the right hand side as so x plus b over 2a all of this squared is equal to b squared minus 4ac all over 4a 4a squared. Now, to find the axis of symmetry, we are going to equate our left hand side of the equation to 0. So we are going to equate plus x plus b over 2a all of this squared to 0. Now, from here, we are going to find x. So whatever that we get for x is our axis of symmetry. Whatever expression that we get for x is our axis of symmetry. So to remove the square, we are going to square root each side. And when we square root here, it's going to cancel the square here. And square root of 0 is also 0, which means that we are going to, so if you square root here, if you square root this part, and also square root 0. Square root of 0 is 0. So we end up getting x plus b over 2a to give us 0, since square root of 0 is 0. So from here, if you are making x the subject, we are going to get x to be equal to negative b over 2a. Now, this expression we've gotten is what we use to find the axis of symmetry of a quadratic function. So whatever function that you are given and you're asked to find the axis of symmetry, we use this expression. That'll be it for today. If you have any questions, please let us know in the comment section. See you in the next video. Bye.